Okay, last part of chapter 6, section 4. Solving polynomial equations is the name of the chapter, but we are going to focus on this part right here, solving polynomial inequalities. Now, we have done this before. It's just now we're going to do the same thing with different types of equations or inequalities. Okay, it's just, well, you'll see when we get to the actual examples. So the steps, very much the same when we did inequalities before. You have to write the inequality in standard form. Right? The inequality in standard form. Folks, this means we're going to take everything to one side. Got to have a 0 on the other side. And we're going to put it in order of descending powers of our exponents. Once we have the inequality in standard form, you're going to find critical numbers by solving for x. And this is going to involve, more often than not, factoring. Okay, so we're going to get everything to one side, and then we got to factor it. And we're going to find those critical numbers by solving for x. Plot the critical numbers on a number line. And just like we did before, we're going to identify the test intervals, and then we have to test. Okay, we're going to do it using sign analysis, right? Because we're going to have our polynomial factored anyway. So we say perform sign analysis. And remember, we just did this not that long ago. You choose a value on the interval. And then you tell if it's positive or negative. Okay, and then the last thing we do is we're going to graph and write the answer using interval notation. And part of the graphing is the shading, right? So you're going to graph and write the solution using interval. You know, that's like negative, positive infinity, or bracket 2 infinity. Okay, we're going to graph, which means shade, and then write the solution using interval notation. All right, well, let's take a look at example 1. Example 1 is already in standard form. Example 1 happens to be quadratic on the left, so this one's not too bad because we just factor. Okay, so we got standard form. We have a 0 on the right. And we're going to factor this. This one's not bad to factor either because leading coefficient is 1 and 3 is prime. So it can only be x and 1 and 3. Signs are the same. They're both plus. This would be 3x, product of the outers, 1x, product of the inners. 3x and 1x is 4x. All right, so write the inequality in standard form. It was already in standard form. Find the critical numbers. we factored it, and now we're going to give our critical values. And that's by using that ZPP, remember the zero product principle. So critical number here is x is negative 1. Critical number here is x is negative 3. All right, so now I'm going to set up a number line. Remember, negative 3 is to the left of negative 1. And this sets up 3 intervals for me. Now we're going to perform the sign analysis part. All right, so to the left of the negative 3, I'm going to choose a negative 5. In between, I'm going to pick a negative 2. And then to the right of negative 1, I'm going to pick a 0 to do my sign analysis. Now remember, I'm putting a negative 5 in here for these x's. Negative 5 plus 1, that's negative. Negative 5 plus 3, that's negative. This is negative, negative. Folks, you can't just say it's negative, negative. You have to give the result. The result here is positive, right? A negative times a negative is a positive. And so now you have to ask yourself, is a positive number less than or equal to 0? Is a positive number less than or equal to 0? And we're like, no. Okay, I'm going to put it was positive here. All right, test a negative 2. If I put a negative 2 in here, that's negative. If I put a negative 2 in there, that's positive. So negative, positive, result is negative. Is a negative number less than or equal to 0? And we say, yes. Yes, it is. This here in between was negative. All right, test is 0. That's going to be positive. That's going to be positive. Positive, positive. Result is positive. Is a positive number less than or equal to 0? And we're like, no. So I'm looking to see where, I have this marked on my number line. I'm like, okay, well, only a negative number is less than or equal to 0. So my solutions are here between. So now I'm ready to give my solution, which is a graph. Equal to means include. So I'm between negative 3 and negative 1, including both of those. And then my solution in interval notation is the interval from negative 3 to negative 1 with brackets. Okay, so just bringing some concepts together of things that we have already done. You could, if you wanted to, at this point, pause the video and try to do example 2 on your own. We just got done factoring these types of polynomials. So why don't you go ahead and pause the video so that you can see if you can get the answer here. Okay, so hopefully you did pause the video and try this one on your own. Notice it was already in standard form, the 0 on the right side by itself. And this polynomial is not quadratic, but it is quadratic in form. We've just got done factoring these types of polynomials. So I factored them both. Notice here, x squared minus 1, that's dots, the difference of 2 squares. That's going to factor further into x plus 1 times x minus 1. This here is the sum of 2 squares. Okay, so that can't be factored. And in fact, if I try to solve this, I'm going to get this is not real, right? Because it's going to be x squared equals the square root, well, x squared equals negative 36, and then x would equal plus or minus 6i. Folks, 6i is not found on the number line. So when these aren't reals, we don't care about this. Okay, these are the only critical numbers we have, there is no imaginary number on the real number line. Okay, so when you get some that aren't real, we're not putting that on the number line. Please don't do that. All right, so in this case, I only got 2 real critical numbers. So that was -1 and +1. I put on my number line, and I set up for my sign analysis. So to the left of -1 would be -2. In between -1 and +1 is 0. And to the right of +1, I chose a 2. And we just go right up in here. It actually technically should be in the original, but I'm in this factored form here. So if I put a -2 in here, that's negative. That one's negative. But guess what? This is never going to be negative. Folks, any number that you put in here for x and you square it is going to be positive. And then when you add 36 to it, it's still going to be positive. Like, even if you put 0 in for x and square 0, that's 0 plus 36. It's still positive. Okay, so for this piece right here, it's always going to be positive. Always. And then we do the same thing like we did in the previous problem. You know, you just substitute these values in here, okay? And you get your minus, minus, plus. Put a 0 in. You're going to get positive, negative, positive, right? Because this one's always going to be positive. And then you put your +2 in here, and here it's going to be plus, plus, plus. This is my final result. Now, I put them on my number line here, okay? So it was positive, negative, and positive. And I'm like, is a positive number greater than or equal to 0? True. Is a negative number greater than or equal to 0? False. Is a positive number greater than or equal to 0? True. And so the shading goes here and here. And so my solution was -infinity up to and including -1, including it because of the equal to, right, in the inequality. And then I pick up a +1, go to infinity. And then my interval notation is this piece in union with this piece. So if you have questions on this, please post in the homework discussion so that I can better assist you with what your questions might be. All right, we have 2 more examples. Let's see what this is going to take to get through these. All right, let's see. Why are these different, or are they different? Oh, I see right away why this one is different. Notice the first 2 examples had 0 on the right side. This one doesn't. Folks, you have to move it over. This has to be a 0. It's not, so I'm going to add it to the other side. So we get x cubed plus 125 greater than or equal to 0. Now I'm looking at the polynomial that I have on the left side. Ah, that is the sum of cubes. You should be able to recognize that 125 is a cube. So this is going to factor into a binomial times a trinomial. All right, this is going to be x, sign is plus, cube root of 125 is 5. Square it, I get x squared, minus 5x, plus 25. We already learned that this can never factor, right? We never can factor this. And in fact, when we try to complete the square with this, we always got something with I. And so I'm not going to have any real zeros here. But I will here. X is -5. So in fact, for this problem, I only have one critical number, -5. I look up and I'm like, yeah, it's an equal to sign. So -5 is going to be included. So either there's no solution here, or the whole number line. That's a possibility. Or maybe just one side of the 5. But one side or the other is, it's going to be a bracket. All right, so let's set up the sign analysis. If I have one critical number, I have two intervals. To the left of -5, I don't know, pick a -6. To the right of -5, pick a 0. It's easy. I already factored it. Remember, I'm not going to get any zeros here. Well, I still need the sign, though. Okay, let's go here. -6 plus 5, that's negative. When I square this is going to be positive 36. Look at this. Negative times negative is positive. This is positive. Positive. All right, put a 0 in here. That's positive. Put a 0 in here. That's still positive. All right, my result. Negative, positive is negative. Positive, positive is positive. So here I'm like negative, bigger than or equal to 0, question mark? No. Positive, greater than or equal to 0, question mark? Yes. So in fact, we do see that only one side of this is going to give me a solution. So my solution, the graph, is bracket on -5, shade to the right, to infinity. And my interval is bracket -5 to infinity. Not too terrible. Just remember, we are not going to get critical numbers with the stuff that's not real, with the I stuff. All right, last one, very similar to example 2. It probably would be good if you paused the video and tried this one again on your own. Okay, hopefully you paused the video and did this one on your own. Similar to example 3, you have to bring the 15 over. And you should have seen, with numbers like 3, 12, and 15, you should have seen that there was a GCF. So we factor out a GCF of 3 to make this more manageable, to make this easier to factor. Okay, remember, you're always supposed to look for a GCF anyway. All right, this is not quadratic, but it's quadratic in form. Once I take the 3 out, the leading coefficient here is a 1, so that makes it easier. Multiplies the 5, subtracts the 4, that would be 5 and 1. Okay, this is dots. Now notice, if you square any number and add 5 to it, it's never gonna be 0. It never is. And in fact, if I take this 5 over to the other side to solve it, I'm not gonna get a 0 there. This thing is never, ever, ever going to be real. It's not going to be real. All right. 3. 3 is not going to be a 0. It's never going to be a 0. So the only two places that I have to get zeros are with these factors right here. Okay, so hopefully you did get this correct. All right, so again, I've got negative and positive 1. I put them on my number line. I do my sign analysis. To the left of -1 is -2. In between here is 0. To the right, positive 2. You can pick a 10. It doesn't really matter. You just have to substitute them back in here. Now remember, this thing doesn't count because this doesn't have an x. So these are my x values that I'm testing. So I sub in a -2. -2 plus 1 is a negative number. -2 minus 1 is a negative number. This is never going to be negative. This thing is always positive. So you see here, positive, positive, positive. All right, put a 0 in. Positive, negative, positive. You see my positive, negative, positive. Put a 2 in. Positive, positive, positive. Get the result of the sign. See, on the last test, some of you didn't give the final result. A negative times positive is a positive. You need this final result. And then you say to yourself, is a positive number less than or equal to 0? No, it's not. Is a negative number less than or equal to 0? Yes, it is. Is a positive number less than or equal to 0? No, it's not. So again, we see the solutions are in between. We give a graph and give our final answer in set notation. So you will see coming up that there is no official review for your your next assessment, your test on this. And it's because we are using the practice worksheet along with the worksheet on the inequalities as a review. There is like a mini review, and I believe that mini review is just problems on these inequalities. There will be inequalities on the next assessment, along with solving the other polynomial equations, solving your cube equations, and solving your trinomials that are x to the power of 4 like these. And then, of course, applying that factoring and using the sign analysis and testing with the inequalities. Okay, so if you have questions, please reach out to me. Ask a question in class. Post something on the homework discussion or come to a Google Meet. Have a great day.